Hi, check out this cool on-air display light I scored on eBay. It's really quite neat. It's one of these etched polycarbonate surfaces like this, so it's actually etched in the back there. It's actually routed in there, and it just lights it up on the edge, and it's really quite neat. I thought, you know, it'd be a nice thing to stick on the wall and have it when I'm actually recording. Makes it feel like a professional recording studio, you know, fantastic. Because one of the more annoying aspects of my Canon HF G10 video camera I'm using to record this blog is that there's no light on top to tell me when it's actually recording, especially not like right in line with the lens. So I'm looking at the lens instead of looking at the screen like this, because what all it has, you've seen these video cameras, very common, they've only got a little record light, one of those little red circles. It's tiny, it's on the LCD. When I hit record, that pops up. Sure enough, it's telling me it's recording, but sometimes I sit here yapping away in front of the camera for 5 minutes and I realize I haven't hit record, or I pressed it and it didn't register, or I pressed it and accidentally stopped instead of started recording, and occasionally I lose info. It's really annoying. So I thought it'd be nice to maybe hack in this thing into the camera. I'm obviously not going to stick this on top of the camera. It'd just be a fun thing to have up on the wall, but it'd be nice if it was synchronized to my video camera, to the actual record function in the video camera. So I thought, maybe is there some way I can hack it into the camera itself? And I don't know if it's possible. So that's what this video is going to be about, a start of an investigation into the LANC wireless standard. This is one of these wired remote controls I've got for my camera. It's not a genuine Canon one, but it allows you to zoom in and zoom out and change the rate of how fast you zoom in and zoom out and stuff like that, and allows you to start and stop recording as well, and set the focus. It's got a few other features which don't work on this Canon camera, because the protocol is called LANC, L-A-N-C, and I believe it's mostly on Sony cameras, but the Canon ones do have it too, and it is a bit of a standard, but not all cameras implement all functions. And I've heard that apparently not only can you send signals to the camera to start, stop, and do stuff like that, but I think it actually sends out data on this one wire bus as well. It's a I believe it's a 5-volt one wire bus. I haven't actually checked it yet. I've just done a little bit of Googling, and apparently it might actually send out some data. So if it does send out a data saying I'm recording, maybe I can tap into that and turn on an LED or something like that. You know, light up or switch a relay which lights up this sign or something. So I thought I'd just have a look, take this thing apart, and try and capture the data on this LANC bus and see what I get. Let's give it a go. Hang on. Oh, I'll show you a really annoying, look, rant time, okay? You design one of these, okay? You're in a quiet recording studio, okay? And look, you can hear the tactile button. It's ridiculous. Why use tactile buttons? Why not use the soft rubber ones so you can't hear them? It's bloody ridiculous. I'm going to press stop now. Grrr. Now this is actually a Bank brand one. It's just one of these cheap, eBay imitation ones, and there are a couple of screws on the back, and annoyingly a couple of screws under the overlay on the top there, and I had to peel that back and get the screws out. But anyway, we are in like Flynn. Here we go. There we go. Ta-da! And we've got one chip on the back, and that's it. Let's take a look at it. And there's not much on here at all. We've got a Holtec brand microcontroller here. They're reasonably common in like very extremely low cost consumer gear. We've got a resonator here, and we've got, looks like some sort of regulator there, and a couple of electrolytic caps, and a few SOT23s and diodes and other stuff. It's got a bit more than what I thought would be in there, but anyway, yeah, there's not much at all. We've got the soft button switches down here, which of course the overlay goes on top. They've got the the carbonized bit on the bottom of the rubber, the conductive bit there, which just shorts out the 2 tracks on the board. We've got these annoying tact switches. Grrr! Why? Generate too much noise, ridiculous. And we've got a rotary encoder switch here to choose the different values for the speed control, and that's about it. Anyway, we've only got it looks like we've got 3 wires coming in. So one is presumably power, ground, and the other's data. Obviously, based on the colors, I'd say white's your data and red's your power and black's your ground. So we should be able to hook the scope onto this thing and capture the data, well, coming out of this thing into the camera, but more importantly to see if anything's coming out of the camera into this board so that we can possibly design our own little widget and capture that data. All right, let's do some measurements here. First off, we've got our ground is on the side of the cap there, so same as the input pins, but it's easier to probe the solder pads there, and we're getting, hey, 5.68. That's rather unusual. That's what we've got coming in on the red and the black wires. Why that's not 5 volts? It's clearly not, you know, your regular 5 volts plus minus 5%. It's not your normal 5 volt supply rail, so that's rather odd. And let's measure the, presumably this electrolytic here is on the output of this voltage regulator, so I don't even need to know the pin out of the regulator, and hey, no surprises at all, 3.3 volt rail. So it looks like the microcontroller is powered from the 3.3 volt rail, and presumably that little, I'm going to guess that that transistor there is the open collector switching transistor for the bus, which pulls that bus line low. That'd be my guess. And I've just soldered a quick and dirty lead onto there so that I can attach my scope probe onto here, and you know, because you don't want to be trying to hold it, you know, probe it on there and operate the scope when you're trying to reverse engineer these things and hack them. It's just not good. So let's hook that up to the scope and see if we can capture anything. And sure enough, we are getting something on there. We're getting multiple data packets. Look at that, no problems at all. Now, one of the problems with my Agilent 3000 series scope here is that it doesn't, it's got really good signal, like many different triggering modes, like a serial decode modes, but it doesn't have one wire bus. So it's, you know, it's just really annoying. So I'll just decode this manually, but what I can just, you know, single shot capture that and have a look, but you'll notice that the triggering's not that stable. It jumps around. So what I'm going to do is just try and, just for the fun of it, not that I really need to, but I'm going to try and get a stable trigger based on the dead period in there where it's high. So to do that, what we do is we capture it here, and we can see we're getting about 10 milliseconds per division here. So it's roughly 10 milliseconds well, it's actually slightly less than 10 milliseconds by the looks of it where it's high. So what we want to do is we want to go into our trigger menu here, and instead of our regular edge trigger, we want to set a pulse width trigger, and we want the sources channel 1, of course, and we want it to be high. So we choose the high one there for greater than, so not less than, but greater than 20 nanoseconds. We want it greater than, let's say, 6 milliseconds, 5 or 6 milliseconds, or to do it, because there's nothing else in there. Oh, getting fussy now, 6.00 milliseconds, let's try that. And so when it detects a 6 millisecond high period like that, it will trigger. So now we should get a very stable trigger. Hopefully, fingers crossed, let's try it. There we go, perfect, bingo. And that's a way to get nice steady triggering on your scope in order to see those packets. Beautiful. So now we can actually single shot capture this, and at first I thought, oh okay, this is, you know, these are individual packets like this, but zooming in, because I knew that it was supposed to be like a 8-bit field. There's supposed to be a start bit and then a stop bit at the end of it. It just didn't seem right. And what's actually happening is this entire packet here is not one packet of data, it's actually 1, 2, 3, 4, 5, 6, 7, well 8, I think 8 packets of data. Now this seems to be matching the information on the I found on a website precisely. We've got one bunch of information here which they call a telegram apparently. So one telegram of information contains those 8 individual packets of 1 start bit, 8 data bits and 1 stop bit. And the distance between 2 telegrams varies but depending on the type of camera. Now I'm in Australia, so I've got a PAL camera. I didn't import this one, it's an Australian version, so it uses the PAL standard, and it apparently has 20 milliseconds between, it's not quite, I haven't got the cursor right in there, I could go in there and set it up, but it's supposed to have 20 milliseconds between the telegrams there, and the NTSC version has 16.6 milliseconds, so I'm certainly getting very close to my 20 there. And each individual packet, 1, 2, 3, 4, 5, 6, 7, 8 of them here, the distance between those is supposed to be 1.2 milliseconds to 1.4, I believe. So there you go, I'm getting we can get in there, I'm getting 1.26 or thereabouts, 1.25 milliseconds between the individual packets. And one of the good things about, and with each bit by the way being 104 microseconds, so if we go in there and have a look at that, we can now, is it 104? It is, bingo, 104, or pretty close to it. And the good thing about this is that apparently the timing is exactly the same as RS-232 at 9600 baud, so maybe I can actually use my serial decode feature after all. So if we go into our serial trigger mode here, we can set it up for UART RS-232, and we can set the signals up. Channel 1 is our receive, we're not worrying about our transmit, we don't have it, and our bus configuration, we can set it up 8 data bits, no parity, the baud rate 9600 bits per second, so we're right there, and the bit order, least significant bit first, so bit 0 first. When you zoom in there, it'll be bit 0 first, 1, 2, 3, 4, 5, 6, 7, 8. So let's give that a go, and we should be able to decode that, and there it is. And it doesn't like that at all, it's decoding the odd bit, but I think we've got our polarity idle low incorrect here. We're idling high, so we need to switch that to idle high, and let's single shot trigger that again. Bingo! There you go, we now have our decoded data. Beautiful, and we can see that changing in real time. Fantastic, because this scope actually does hardware decoding of this serial interface in real time, so we can even trigger off certain data bits or certain bytes if we want to. Now, because this is continually changing like this, and I'm not pressing any buttons on the remote control, then I'm going to presume that the controller, the wired remote control, doesn't actually send any information until you press a button. It just wouldn't make sense to do that. I could be wrong, but gut feel says it's not going to do that. So clearly data is changing here, so this indicates that this is changing data being output from the camera. So I think the camera is well and truly outputting some sort of data, either a time code or something like that, which I've read it actually might do. So because that almost looks like it's doing some sort of counting, you know, very fast, some sort of counting thing as it goes up or something like that. It's certainly outputting some sort of information, and then we're getting this blip, 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 blip thing happening here. I'm not sure what's going on there. All right, now let's see what happens here. If I press the zoom button, bang, look at that. The first 2 bytes there first 2 packets are changing. The other ones seem to be continuing on their merry way. And if I hold it down, let's zoom into those first 2 packets, shall we? There we go, so we're in there. Let's turn off the cursors for a minute. And let's press the zoom out, I think it is. Bingo, look at that. Those 2 bits certainly changing. And so what it looks like happening here is that like the first 2 bytes are input bytes. So they're input bytes to the camcorder, whereas these ones over here seem to be output bytes that are outputting information. So the first one, so if I press the zoom out, I believe, there's that consistent pattern there. There it is. And if I do the other one, zoom in, bingo, it's exactly the same. The first byte's exactly the same if I alternate between the 2. But you'll notice that this second one here, that zoom out and zoom in, doesn't have that. Bingo. That works really well. So it goes from FF to, so we're looking at D7 there in hex, of course. D7 and FD is the zoom in, I believe, and then zoom out. Aha, look, the data bit's changing because I've changed my rotary encoder, so it is now zooming in and zooming out as I press those buttons. But if I put my rotary encoder to a certain spot, I can get it. So it actually, look, yeah, it's changing. Okay, so doesn't look like there's a fixed code based on just the zoom in, zoom out. It's a code based on what level of zoom in and zoom out you have. So if I hold, let's say if I hold down zoom out and I change the rotary encoder, it's not a rotary encoder, it's a switch. There we go. So I'm turning the switch and it's cycling through. Bingo. There you go. It's got a different command. So there it is. As I press these switches, and so I hold in the zoom and I can touch the switch, faster, 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 slower, to a point where I can actually get it to, yeah, it's tiny. So you hardly even notice I'm holding that and it's slowly zooming out. There we go. So that's rather neat. We're certainly capturing this data and it looks like it is outputting data here. Then that's really what we're interested in. And what I'm doing quickly now is just pressing the record off and on. Now obviously I can't capture the screen the same time as I'm not recording, but I can't see any differences in these packets here, these bytes here, these 3 which are after the first 2, so that's byte 2, 3 and 4. I can't see anything in there when I start and stop the record button. I can't see anything change, so there's nothing happening there. And of course I don't have to dick around trying to reverse engineer this because somebody else has already done it for me and the info is on that website. But it doesn't mean it's going to be specific to this particular camera though, because not all cameras, especially Canons, don't implement everything. But it basically says that the 4th packet here, the 4th byte, is the one that contains the status information coming from the camera. So we've got byte 0, 1, 2, 3, 4. So that one in there with the double bit, that's the one, the double low there, that's the one we're interested in. That's the one we want to see, and we'll see if it changes. So I'm going to press stop here and see if there's any difference. No, unfortunately not. I pressed stop and that packet did not change at all. That individual byte didn't change, not a sausage. Didn't see a damn thing. That's disappointing. That's supposed to be the status coming from the camera. So maybe this whole idea is shot down right there. Maybe this Canon camera just does not output its record, stop, play, pause status. Bummer. And these last 3 packets here, I'm not seeing any change there at all. We're getting data out of it, but I don't care too much about that. I'm pressing stop and start and record here, and I'm not seeing, it's just, it's just outputting a whole bunch of data, which might be some sort of time code, but I can't see any like fixed individual bit change in there when I press start and stop. So this is not looking at all promising. What a bummer. Well, I think I've had enough for today. I can't find it. I expected to see at least one of those bits in there sort of toggle when I pressed the record button, but unfortunately I'm not seeing that at all. I'm going to have to review the footage again, play around with it some more, but I think I'll call it quits for now. But anyway, that was an interesting first investigation anyway into the LANC bus and what it outputs from this Canon HF G10 camera. So it's worthy of a bit more investigation. So if you noticed something on the video, or you know something more about it specifically for this Canon or Canon cameras in general, please let me know. Jump on over to the forum or put it in the comments or something like that. So I hope you enjoyed that. Just a quick little sort of hack debugging video there. And as always, if you like the video, please give it a thumbs up, and I'll catch you next time.